Imagine a future where Earth is no longer the only home for humanity. How would we survive and thrive in the vastness of space? This question is no longer confined to the realm of science fiction. It's a question that scientists, explorers, and dreamers around the globe are grappling with today. Why? Because the cosmos, with its infinite expanse and myriad mysteries, beckons us. It whispers of untapped resources, of worlds uncharted, of the potential for new beginnings. And because, let's face it, the survival of our species may one day depend upon it. This video is not just about the what-ifs, it's about the how. How might we venture forth from our cradle Earth and set foot on alien worlds? How might we build a life amidst the stars? Join us as we delve into the science and possibilities of human survival beyond Earth. A cosmic disaster could render Earth uninhabitable. What would cause such an event? Well, the universe in all its magnificent vastness is not without its share of perils. In fact, it's a cosmic shooting gallery out there. And Earth, our blue marble, is not immune to the dangers. Picture this, a rogue asteroid hurtling through the void of space on a collision course with Earth, just like the one that is believed to have wiped out the dinosaurs 65 million years ago. We know from studies of our planet's history and from observations of other celestial bodies that asteroid impacts are not just the stuff of science fiction, they are a real, albeit infrequent occurrence. NASA and other space agencies are constantly scanning the skies for near-Earth objects that could pose a threat. Then there are the gamma-ray bursts, the most powerful explosions in the universe. These occur when massive stars collapse into neutron stars or black holes, releasing a torrent of deadly radiation. If Earth were to be hit by a gamma-ray burst from a nearby star, it could strip away our ozone layer, exposing life to harmful solar radiation. And let's not forget about solar flares, sudden eruptions of energy from our very own star, the Sun. While our atmosphere and magnetic field protect us from most solar radiation, an exceptionally large solar flare, often referred to as a superflare, could potentially disrupt our electrical systems and damage our ozone layer. These are just a few examples of the cosmic catastrophes that could threaten life on Earth. While the probabilities of these events occurring are low, they are not zero. And as we've learned from studying the universe, what can happen will happen given enough time. This realization, this understanding of our precarious position in the cosmos, is part of what drives our exploration of space. It's not just about the scientific curiosity or the human spirit of adventure, it's also about survival, about ensuring the continuity of our species. The threat of cosmic catastrophe drives us to consider a future beyond Earth. Scene script: space is vast, the distances are mind-boggling. How can we traverse such enormous distances? This is the distance dilemma. The nearest star system to us, Alpha Centauri, is over 4 light-years away. If we were to travel at the speed of light, it would still take us 4 years to get there. But the fastest spacecraft ever launched by humanity, the Parker Solar Probe, would take thousands of years to reach Alpha Centauri. Clearly, we need something faster. Enter the world of advanced propulsion systems. Ion drives, which use electric fields to accelerate ions and push the spacecraft forward, are one possibility. They are highly efficient and can reach high speeds over time. However, they still fall far short of the speeds we would need to travel between stars in a reasonable time frame. Nuclear propulsion, where nuclear reactions provide the energy to propel a spacecraft, offers another option. This technology could potentially reach speeds up to 10% of the speed of light, but it comes with its own set of challenges, including safety concerns and the difficulty of managing a nuclear reaction in space. And then there are the more speculative concepts like warp drives. These are purely theoretical at this point and would involve bending or warping space-time to effectively jump across space. While exciting, the science behind this is still in its infancy and it may turn out to be impossible. Beyond propulsion, there's also the question of time. Even at high speeds, interstellar travel would take years or even decades. How can we manage such long journeys? Would we need to put humans into hibernation or build generation ships where multiple generations of people live and die during the journey? These are complex questions with no easy answers. Overcoming the distance dilemma is a significant hurdle in our quest for survival in space. But as we've seen throughout history, humanity has a knack for overcoming hurdles. Who knows what ingenious solutions we'll come up with in the future? The journey may be long and fraught with challenges, but the destination, a new home among the stars, could be well worth the effort. To survive in space, we need to replicate Earth's life-supporting conditions. How can we achieve this? Imagine our blue planet. Its unique blend of oxygen, water, food, and protection from harmful radiation makes it a sanctuary for life as we know it. But how can we replicate these conditions in the cold, unforgiving vacuum of space? First off, let's consider oxygen. It's a vital ingredient for human survival. In a spacecraft, the air we exhale, laden with carbon dioxide, needs to be scrubbed clean and replenished with oxygen. This is achieved through a process known as Environmental Control and Life Support Systems, or ECL-SS. This technology is currently used on the International Space Station to recycle approximately 95% of the water and 84% of the oxygen on board. Then there's the question of water. We can't exactly install a tap on a spacecraft and expect water to flow out. The solution? Water recovery systems that recycle moisture from the air, urine, and other waste. This sounds a bit unappetizing, sure, but this technology is crucial for long-term space travel. Food, of course, is another essential. Astronauts can't pack a lifetime supply of food for extended missions, so we need to find ways to grow food in space. Scientists are exploring hydroponics and other forms of space farming to produce fresh, nutritious food for astronauts. Finally, we have to consider radiation. Space is filled with high-energy particles that can cause severe health problems. To protect astronauts, spacecraft are equipped with radiation shielding. Future technologies may even include magnetic fields to deflect these harmful particles. In essence, to venture into the cosmos, we must carry a mini Earth with us. We need to create a closed-loop system that can support life indefinitely, recycling and renewing resources just like our home planet does. It's a complex and challenging task, but it's also an essential one. After all, our survival in space depends on it. Creating self-sustaining life support systems is essential for long-term survival in space. Long-duration space travel might require humans to hibernate. Is this science fiction or a realistic possibility? Let's delve into the fascinating concept of human hibernation, or as scientists prefer to call it, torpor. This isn't just a plot device in your favorite sci-fi movie, it's a real field of study with potential applications for long-duration space travel. Imagine being able to sleep through an entire journey to Mars or even further afield. Not only would this solve the problem of boredom during a potentially years-long journey, but it could also significantly reduce the resources required for the trip. Less food, less water, less oxygen, less space, less everything. In nature, many animals hibernate to survive harsh winters when food is scarce. They slow their metabolism right down, reducing their need for food and energy. But can humans do the same? Well, believe it or not, medical science has been studying induced hypothermia and torpor for years, mainly for therapeutic applications. Lowering a patient's body temperature can help to reduce damage during heart surgery or after a stroke. It's not quite the same as hibernation, but it's a start. Now, let's take this concept a step further. Scientists are researching ways to induce a state of torpor in humans that could last weeks or even months. This involves not only lowering body temperature, but also reducing metabolic rate and suppressing other bodily functions. The European Space Agency has funded research into human hibernation, and NASA has also shown interest in the concept. One project, called Torpor-Inducing Transfer Habitat for Human Stasis to Mars, even proposes a spacecraft design with sleeping pods for hibernating astronauts. But we're not there yet. There are still many unknowns. How would our muscles, bones, and immune system cope with prolonged inactivity? How would our minds react to such a long sleep? What are the potential risks, and how can we mitigate them? Human hibernation could be a game changer for space travel, making the impossible possible. The journey is long and the challenges are many, but with each new discovery, we're getting closer to turning this science fiction dream into a reality. If we leave Earth, where could we go? What new homes await us in the cosmos? Our first stop might be our very own cosmic backyard, Mars. With its day length and seasons similar to Earth, Mars is a tempting destination. However, its thin atmosphere and lack of magnetic field present serious challenges. It would require us to create pressurized habitats and ways to shield ourselves from harmful solar and cosmic radiation. A more speculative option is the concept of terraforming, transforming a planet's environment to make it Earth-like. This would involve monumental feats of geoengineering, like releasing greenhouse gases to warm Mars's surface, or even crashing comets into the planet to provide water. Beyond Mars, the vast cosmos beckons. Exoplanets, planets orbiting other stars, offer tantalizing possibilities. Scientists have already discovered thousands of these distant worlds, some within the habitable zone where conditions could potentially support life as we know it. These exoplanets could be our future homes, but reaching them would require overcoming the immense distances between stars, a challenge that pushes the limits of our current understanding of physics and technology. Then there's the concept of artificial habitats. Imagine colossal space stations spinning to simulate gravity with vast interior landscapes that mimic Earth's environment. These could be built from materials mined from asteroids or the moon and could house millions of people. In these self-sustaining habitats, humanity could truly become a spacefaring species. Yet, all these options come with their own set of challenges. They require advances in technology and a level of understanding of the universe that we are just starting to grasp. But with every new discovery, with every step we take into the cosmos, these distant dreams come a little bit closer to reality. Finding new homes in the cosmos is a daunting but exciting prospect for humanity. As we gaze out into the universe, we are not just spectators, but active participants in this grand cosmic adventure. With the challenges and possibilities we've discussed, what does the future hold for human space exploration? The future of space exploration is both a scientific and imaginative journey, a thrilling blend of hard facts and daring possibilities. As we stand on the precipice of venturing beyond our own world, we find ourselves in a unique position. We are not only explorers, but also creators, shaping our future among the stars. Looking at current scientific advancements, we can see the beginnings of what may come. We have rovers on Mars, telescopes peering into the farthest reaches of the universe, and plans for manned missions to our neighboring planets. But that's just the tip of the cosmic iceberg. Space agencies and private companies alike are pushing the boundaries of what's possible, developing advanced propulsion systems, life support technologies, and plans for sustainable habitats. The Moon and Mars are within our grasp, but we are setting our sights even further. Exoplanets in distant star systems, once the stuff of science fiction, are now becoming potential destinations for future explorers. But as we gaze into the future, we must also engage our imaginations. We might consider concepts that seem fantastical today, like warp drives and wormholes, or intriguing theories like the existence of multiverses. We might dream of colonies floating in the void between stars, or terraforming planets to create new Earths. The future of space exploration is not just about survival, but about the expansion of human potential. It's about our insatiable curiosity, our unwavering determination, and our innate desire to push the boundaries of what we know. It's about discovering new worlds, challenging our understanding of the universe, and ultimately finding our place within it. Of course, the road ahead is fraught with challenges and unknowns, but as we've seen throughout history, these hurdles often drive innovation, propelling us forward in ways we can't yet imagine. So, as we stand on the cusp of a new era, we look to the stars with anticipation and resolve. For in the vastness of space, we see not only the challenges we must overcome, but also the boundless opportunities that await. The future of human space exploration is a thrilling blend of science, technology, and human spirit. Humans have always been explorers. We've crossed oceans, climbed mountains, and now we look to the stars. Our curiosity, our insatiable desire to discover the unknown, has driven us to the brink of interstellar travel. The spirit of exploration is not just about geographical conquests, it's about pushing the boundaries of our knowledge, our technology, and our resilience. It's about the audacity to dream, to imagine possibilities beyond our current understanding. This spirit fuels our quest to survive in space. It compels us to unlock the secrets of the cosmos, to adapt to alien environments, and to innovate ways to sustain life far from our home planet. It's about a relentless pursuit of progress, even in the face of immense challenges. Our journey to the stars isn't just about survival, it's about our collective desire to learn, to grow, and to evolve. The spirit of exploration is what might ultimately lead humanity to a future beyond Earth. Our journey into the science of human survival in space has been fascinating. We've delved into the necessity of space colonization, the hurdles of long-distance travel, and the complex systems needed to sustain life beyond Earth. We've considered the concept of human hibernation and potential celestial destinations. Above all, we've contemplated the future of our species, driven by an insatiable curiosity. The quest for survival in space is a testament to human ingenuity and the unyielding spirit of exploration. As Carl Sagan once said, "Somewhere, something incredible is waiting to be known." We hope you enjoyed this journey into the future of humanity in space. It's a voyage of discovery filled with endless possibilities and incredible challenges. As we continue to explore and learn, we invite you to join us on this extraordinary expedition. So let's venture together into the unknown, uncovering wonders and pushing boundaries. Stay curious, stay inspired, and join us for more adventures into the future of humanity. Remember to like, share, and subscribe for more fascinating insights.